Hello, everybody. I'm Robert Krnjevic. I am a data evangelist or a data advocate in Silicon Valley at Hortonworks HQ. And today we're going to cover Apache Spark. We're going to split it in two portions. One is going to be about an hour or so, mostly high-level review, focusing on the different modules of Apache Spark. And then we're going to have the lab, which is the hands-on portion. Before I go, I would like to see maybe a set of hands. How many of you have used Spark before? Okay. How many of you are coming with the interest on the data engineering side? All right, a little more than half. And data science? Both? All right, wow, that's quite a few. Okay. If you haven't connected already, please do connect to this SSID, the crash course SSID. You should also have a little paper on your table. This will be relevant because we want to make sure you have a really good high-speed connection when we do the labs. All right, so let's briefly talk about data. You've heard a lot today during the keynote, but there's a lot of data that's being generated, whether it's Internet of Things, user-generated content, social web, etc. And the data is growing rapidly. By extrapolation, over 50 zettabytes by 2021. And there's the difficulty of, the big problem of how you actually manage all this data. On one hand, you have, the single machine that cannot process or even store all the data. That's why we're talking about distributed, map reduce, and now Spark with its own engine. And the solution is to distribute everything across large clusters. The difficulty always is, how do you split it across the machines? How do you move the data across the network nodes? And moving across network nodes is generally expensive. You must consider where's the data, what's the data locality, a network locality in and of itself, how do you deal with failures, and of course, how do you deal with slow nodes? So Apache Spark in and of itself is, a distributed and general processing engine, and it operates across different workloads. We're going to discuss and touch briefly about streaming, SQL, machine learning, graph, etc. And one thing that Spark does and is really good at is accessing different kinds of sources. So whether it's Hadoop, whether it's Amazon S3 objects, stores, age-based Cassandra, etc. Why Apache Spark? Some of you have already used it. It seems like most of you have. You've probably seen the APIs. The APIs are very elegant, and it's really good for all kinds of workloads, whether it's data munging, wrangling, or machine learning. Why is it fast? It's mostly because it's in memory, so it's got the fast computational model. And for machine learning, it implemented distributed machine learning pipeline. So the reason this is actually important is, if you're doing Python and you're using the scikit libraries, it's great for starting with data science. But as you put in the petabytes of data, as you really go into a big data environment, you need to distribute it. And so a lot of the machine learning libraries have been rewritten to work in that way. You also have what's called the pipeline API, which we'll discuss today. And you can also bring external libraries via different GitHub repositories, or you can even go to commercial route for additional libraries as needed. So the excuse me. So the 4 core modules, again, will be the Spark SQL for processing structured data, Spark Streaming for real-time data, Spark Machine Learning, and GraphX, which we'll briefly touch at the very end. So let's start with Spark SQL. Before I go there, it's worth mentioning that there's 2 different types of data. On one hand, you have the structured data, structured, and it's in a specific format. So for example, ORC, or row columnar format, an optimized row column format, or Parquet. You have serialized formats such as Avro, which doesn't have such a flexible schema. On the other hand, you have the unstructured data, actually pointing this way, which is text, which is data that's not tagged, which doesn't have metadata around it, which doesn't have structure around it, and then in the middle you have the semi-structured data, such as XML files or JSON. So when it comes to Spark SQL, There's two ways to manipulate data. One is using what's called the data frames and dataset API, and then there's the SQL queries. What we're going to do today is I'll briefly touch on both and basically show you that when you actually write the code, whether it's using the data frame APIs or you run the SQL queries, the end results are the same, and the underlying timeliness of actually delivering these results is the same as well. Before we move farther, probably already many of you know, especially with Spark 2x, the main entry point is the Spark session. It allows you to program with the data frame and dataset APIs, and in the notebooks themselves and pretty much everywhere else, it's represented as Spark. In the notebooks that we're going to touch today, the Zeppelin notebooks, it's auto-initialized. It's actually auto-initialized Jupyter as well, and it's represented as Spark. So with data frames, what are they? Probably many of you already know, but essentially they're a distributed collection of data organized into named columns. You can think of, SQL type of engines where you have the columns and the rows and the underlying schema. So they are equivalent or very close to your relational databases. You can program and manipulate them in R and Python, or it's similar to the R Python data frame, and you can manipulate it and write the code in Scala, Java, Python, and R as well. So the point about this one is that you have the flexibility of the different languages of writing the code in Spark, which is also very good. So again, the Spark SQL can bring in the data from different sources. It could be JSON, Avro, CSV, or the Hive tables, and then once you process it, creates this underlying data frame that we'll be manipulating. So the example for the data frame, in this way what we're going to do is go briefly through some of the sample code. Right here what we're doing is we're just bringing a flights JSON dataset, and we're specifying the path with initializing the Spark, the entry point, and reading the JSON file from there, and we're storing it in the flights data frame. And the next step what we're going to do to show the comparison between the different ways of interacting with Spark SQL module is we're going to create a temporary view. We're going to call it flights view, and that will allow us to reference to it as a table. So now there's two ways of addressing this data and reading the data from Spark. One is the data frame API, which here, as you can see, all we do is we have the flights data frame that we've brought the data in using the JSON reader. And basically, we're just selecting three columns. We're selecting the origin, destination, and departure delay. This is, again, the flights data set. And we're filtering on the departure delay column, showing only those that are delayed by more than 15 minutes. On the other hand, you have the SQL API. As I mentioned previously, we've registered the flights view table. And we're doing the same thing, selecting the origin, destination, departure delay, and we're basically doing where departure delay is greater than 15 and limiting it to 5 results. And the result is the same. The result is the same because underlying it uses a Spark core, and the Spark core translates to the lower level language, the RDDs that are underlying it, and the code executes in the same time. All right, Spark streaming. So you have two ways of processing data. On one hand, you have a way to go with batch processing. So that allows you to analyze data at rest, or the data that's been stored in your data store, in your data lake. And it's request-based, so generally just processing a bulk of data, the data that's been stored there for a while. And it allows you to do retrospective, reactive, and on-demand type of analytics. On the other hand, stream processing, right, is the data that's in motion. Most common, the default API is doing the microbatch, so it's microbatch driven, continuous, and long-lived processing, and it enables real-time, prospective, proactive type, and predictive analytics. When you combine the two, it's really all data analytics, so both the stream and batch processing, really what we see in our workloads. So we have two types of approaches. One is the traditional analytics, when you ask the questions and then you write the query, and the next generation analytics, which hopefully everybody's kind of looking at is it's a data-driven, so you have the data, it allows you to explore and get insights from the data, and that provides you with the information that you're looking for. So the Spark streaming is essentially an extension of the Spark Core API. And again, it's scalable, it's a high throughput and fault-tolerant system. It connects to different data sources, whether it's Kafka, Flume, HDFS, Kinesis on Amazon. Some of these earlier ones are no longer supported. If you're still on Spark 1, then the 0MQ, etc., are no longer supported default. You need to bring in as additional libraries. And then, of course, once you process the streams, you can store it in HDFS, databases, and dashboard. And it's important to say store it because Spark in and of itself doesn't have a storage, so you always have to have it connected to bring the data from somewhere. You either point to S3 or it sits, for example, in a Hadoop cluster, and it brings data from your data lake, which at this point will be HDFS, and in the future, other types of object stores. So really what happens is the default way of Spark streaming, and really pretty much all the streaming that's been done until Spark 2.2, is been through a micro batches. So you have an input of data, a stream of data that's coming in, and then it's split into batches of data. And generally, the recommended batch size is every no less than half a second. And then the Spark engine processes whatever the functions you want it to have, and it outputs a batches of data. So it's a batch that comes in. So every half a second, you have a batch of data, you process the data, you spit out an output of that process. So what happens, one of the concepts in Spark streaming are the discretized streams. Again, it's a high-level abstraction, and it represents the continuous stream of data. Internally, it's represented as a sequence of RDDs, or resilient distributed data sets. If you started with Spark quite a while ago, you've probably learned the RDD API. Now, with the data frames and the dataset APIs, it makes no sense to do an introductory crash course, so we're raising the level. So we're covering data frames, which internally has a lot of optimizations underneath, so you don't have to deal with as many parameters, you don't have to do a lot of caching, all that stuff is done mostly for you. So that allows you to be more effective as a developer. So again, it's basically the discretized stream, and it goes, RDD at time 1, RDD at time 2, and it chunks it up from and for those time ranges. So for example, the flat map operation, which many of you are probably familiar with, it takes lines of data from time 0 to time 1, and it applies it on this, every single batch. So again, you have these batches, and it processes these batches, and it outputs that transform information. Of course, it also allows you to do a lot of window operations. So the window operations, for example, rolling average, if you're in the financial industry, you want to look at the rolling average over 3 time sequences in this instance. So for example, you want to see what is the rolling average over the last 4 quarters, over the last 7 days, et cetera, et cetera. This is a this is a Scala sample code. So here what you have is, for example, you have window word counts, and you're having a reduce by key function, or by key window, and it basically takes these 2 variables. This one, I believe, goes, so last 30 seconds of data every 10 seconds. Yeah, so that's the very last one. So you have every 30 seconds looking at the last 10 seconds, every 10 seconds for the last 30 seconds of data. So some of the challenges in streaming data are consistency. Is the data in and of itself consistent? Is it fault tolerant? So when a failure occurs, can it recover from that failure? So if one of the node fails, does it have automatic and clean failure recovery? And of course, does it process and allow you to deal with out-of-order data? So some data might come earlier, some data might come later, and you want to make sure that that data is dealt with properly. An example right here would be, for example, you have, let's see, you have some events that are open and some events that are closed. And it's important to have a knowledge of when you actually when you're actually recording the data for the final solution, you want to make sure that, for example, when you have open event, that the same number of open events is as there are the closed events, which then you don't want to have, for example, more closed events than open events, because that would not make sense. So again, out of order data is dealt with here automatically, and that's when structured streaming comes to play. So it provides high-level APIs. You got the data frames, data sets, and SQL, like I mentioned, and it's both the same in dealing with it and streaming as in batch. It allows you for event time processing, so it's got the native support for working with out-of-order data and late arriving data. So some data might arrive, a few hours later. This is especially relevant to, when you have some IoT systems. Sometimes they lose connection, and some data might arrive much later. And the cool part is that it's end-to-end exactly once. So you don't overcount the number of events that are coming in. So what structured streaming, that's common especially with Spark 2, Spark 1, has been the tech preview. What allows you to do is have a lot of these features which, if you're trying to develop them on your own, would take a lot of your time. So this is something that's very useful. From the structured streaming and basic, essentially you can think of it as an unbounded table. And the new data is basically the rows that are being appended to this unbounded table. So the table just keeps growing as more data is coming in. So as you have the input and data is coming up to a specific time or up to specific time, for example, t equals 1, t equals 2, t equals 3, you have the results and you process them in real time. But the output is a complete node with all the calculations and making sure that it addresses all the different steps that have taken place. So this is actually a pretty cool example. So what happens is some of the events have arrived much later. In this case, the dog event that occurred much later isn't actually calculated until 12:15. So you have this dog that's been much earlier, but it arrives much later, and it can still update the counting of this table, especially relevant to window type of aggregations. So you have these counts that reflect the actual past that happened, and there's no double counting, and making sure that these events are actually processed correctly. So the Spark MLlib module, which is for machine learning, is really relevant for many of the pipeline types machine learning applications. So two key things to remember about machine learning, and two key functions that you'll be using are fit and transform. Fit being for training, and transfer being for the actual prediction. So when you actually build your pipelines, and most data scientists will split the data 80-20% or 70-30%, where 80 or 70% is the training data, and then 20 or 30 data is the data that's been reserved to do the actual testing. So you randomize the way you go about the data, and you would say 70% of the data I will use for training this model, and then 30 to 20% I will use for testing the model, to making sure that you're not testing other data that's been seen previously. So what you do is you have these data frames. Again, going back to Spark SQL module, you push it through the pipeline, and I'll go over what types of things can go in the pipeline. And then you have this input data frame, the test data frame, where you push it through the actual pipeline model if you apply the fit function, and then you apply the transform to actually see what's the output data frame, to actually see the predictions. And then you can, for example, measure the accuracy of these models. You can measure different functions. What is the accuracy, what is the area under the curve, etc., and so forth. So here are the different steps. In your pipeline, you could have multiple things. So oftentimes what you'll do, especially in machine learning, you'll do multiple steps such as feature transform 1, feature transform 2. Then at some point you might want to combine the features and apply one of the machine learning models, in this case, linear regression. Once you export the model, you then go again and you would do the prediction to see whether the output performs as well as not. If not, then you, for example, switch out the last piece, which in this case is the linear regression model, and you can replace it, for example, random forest trees, etc., to make sure that you get the model that you want that performs to your metrics. One important part here is that once you actually do the feature transformation 1, 2, etc., and you combine the features, that piece pretty much stays constant, right? This is where you've done a lot of the engineering, you've done a lot of the transformation. Of course, things could change. As I'll be talking about the data science crash course tomorrow, big part of it will be, what are the relevant features, what are the relevant pieces, and what we have to do to make sure we actually get as high-level results as possible. Sometimes, there are duplicate features, sometimes less relevant, but generally, once you have this pipeline or this workflow designed, that in and of itself helps you a lot to accelerate the final process, which is, in many ways, the coolest one of actually training the models. So here, let's look at the code briefly. So, for example, the 4 different pieces that went into that pipeline here. For example, we have some kind of indexer, we have a parser, we have a hashing transform, and of course, a vector assembler to assemble of this. So what happens here, actually I have this cool laser. So at this point, what we're going to do is we're going to call this random forest classifier, and we're going to specify 100 different trees. So briefly about machine learning, you have the decision trees, but when you combine the multiple trees, that's what's called the random forest. So what we do, we're specifying that, in this case, there's an external parameter, a hyperparameter, and what we're doing is we're specifying that we're using 100 trees to apply on this random forest classifier. That's the parameter that you have to specify externally. And then the pipeline that you've seen before, basically you specify the different stages. So again, these over here are the indexer, parser, hashing, transform, and vector assembler. And the end, we're applying the random forest function. So in the end, again, what you're doing is, this is just a very high level, but focusing purely on the machine learning, like the key elements that are going into the machine learning itself. And you're applying, again, the fit to actually train the model, and this is your training data. So again, that could be your 70 or 80% of data that you've left, that you've set for training, and then you apply it to this pipe over here. So now you have your model, and now if you want to test the model, then you have your test data. This is the 20-30% that you left for actually testing the model, and you apply it on this model to get the results. So from that, you can actually evaluate how good the model is. So again, you can export your models. One of the popular formats is the predictive markup language. It's XML based and supports. This is actually pretty old. I should update this. Some time ago, it supported just a few models, but now it supports way more. But here are some of the more popular ones. And before I go to Spark GraphX, any questions so far? Because I know I went pretty quickly, but it's the essentials, the very high level stuff, and the lab itself will have more code that you can play with. Is this pretty good? I don't want to bore you to death. I don't want to go too slow because I know it's been a long day, and this is very late in the day. Some of you have traveled from afar, so I'm going pretty quickly. But hopefully the hands-on portion, will get you guys excited again, and we'll keep moving. So again, the GraphX. From the community perspective, GraphX haven't received that much attention. I've played with it a little bit before building some interesting decision trees and graphs. Here's a cool example, and you can actually read more about it. There's been a few blogs on, for example, analyzing the community. So something that Facebook, for example, could be doing. There's one piece that you could apply is, actually, let me go back. Of applying, finding the hyperlinks and applying a PageRank algorithm, right? So now you can have these top 20 pages, very useful, something that Google does. You can do topic modeling, basically doing a clustering with LDA. So now you have your words and topics that are similar, and then of course you can do something like community detection. So you can see which communities, which people interact with each other. If you're looking for core contributors to Wikipedia, to certain articles, you can use some of these algorithms, and then you can detect people that are outside of these communities. So you can create the user communities, and then For example, you could create another table that would say, well, this is the community topic. So topics by community by combining, for example, these two different outputs. So there's a lot of cool and very powerful stuff that you can do with this. But of course, like everything else, it takes a bit of time to deal with. Go ahead. Yep. So this way, this was actually, go ahead. Oh yeah. So the question is, how do you create the metadata where you find the information? How do you create the links? Yeah. The nodes and the links, right. So in this part, basically you have you take the raw Wikipedia, you do some pre-processing, you could have an XML document which specifies, thank you, Raphael, which specifies your nodes and edge nodes and your edges and how they're connected, and then you could use that to actually build it out. This specific example is based on Wikipedia. So for example, can you find the communities? Can you find the people that interact with each other? Can you use some of the machine learning algorithms to then find, what are the topics for the specific communities? So I'll show you an example of what it means to actually build a graph. So in this one, you have a property graph. So you have a vertex table. So in this case, your vertices, 2, 3, 5, and 7 would specify the property, who that is. For example, he's a student, he's a postdoc, he's a professor, etc. And then you have the edge table, right? So something that you could extract similarly with the Wikipedia information. And in the edges, you would then describe, that the property between 3 and 7, let's see 3 and 7, you got 3 and 7, they are collaborators. And let's see if we go from source ID, 3 as a student and 7 as a postdoc. So they will be collaborating on a thing. So you can define these relationships, which are super useful when you do graphical type analysis. Let's see. If we go 5 to 2, let's see, 5 is a professor, 2 is a professor. So a colleague makes a lot of sense. And then you have, let's see, 2 to 5, yeah, colleague. So then you would specify the edges over here. So it would be another table. So you have these tables that would describe, one would be the vertices or the nodes, and that could be some property. Here will be, what's the student, professor, etc. And then the edges in this case would be, what is the relationship? Whether one is advising the other, whether one's a colleague. And of course, these are directed edges. So you see that, from 5 to 7, that's a specific relationship, right? Because, let's see. So 5 to 3 is an advisor, right? Let's see, 5 to 3, because 5 is a professor and 3 is a student. But the other way around wouldn't work. So you would have to specify a different source of destination. So you have to flip these. So that would have to be a source, and then that would have to be the destination to have that, a student to a professor is someone who's actually learning from him, right? He's not really an advisor. So making sure that the relationship from whom to whom takes place is relevant here as well. So many of the GraphX algorithms, such as the ones that I mentioned, PageRank, connecting components, SVD, etc., are there. Simple GraphX code. This one basically takes the vertices and edges, the vertices and edges that have been specified before. If it's a text, unstructured text, right? It's been pre-processed, so you kind of have the basic relationships. You might do some basic machine learning on that or text analysis. And then what you do is you specify another source, for example, of messages, and you could join the vertices on the messages, and then you have these IDs, vertices, and the messages that are combined. So this is a very simple, condensed way of talking about and specifying the different graphs interaction and joining vertices. So again, you have these join functions that you can perform. All right, before I go to Zeppelin, any questions on Spark so far? Yes. Uh-huh. So right now they've, it's a little bit confusing because they call them Spark ML, now they're calling them again Spark MLlib. But, oh yeah, I keep forgetting. So yeah, so basically you have the Spark ML and the Spark MLlib in production, right? So which one should you be using? Well, the latest one, right? But that's an easy one. So yeah, so they've called it Spark ML. Now they keep calling it Spark MLlib again. So that's the default. The libraries, as far as the Python libraries, the R libraries are the latest and greatest. And when I say the greatest, they've done a lot of optimizations. They fixed a lot of bugs. So basically, whatever the libraries come in Spark 2.3, if you should update them. As quickly as possible, because then you have the latest and the ones that are most stable. I know that's a really general way of, I know, that's a really general way of answering this, but there are continuous improvements if you look at, different releases of Spark, what has been changed, what has been updated. All right, so any more questions? Once, twice, thrice, okay. I'll be here after that, after I start the demo, the hands-on portion, so you can just come here and ask me any questions, and we can have more of a chat if you actually have something specific. But before I go, so part of the lab today will be focusing on Apache Zeppelin. There's a lot of notebooks. Jupyter's been around for a very long time, and I think most people are comfortable with Jupyter. Zeppelin, for a long time, had some stability issues. Most of them have been resolved, and the next version will be Zeppelin 0.8, and after that, likely Zeppelin 1.0. So at this point, it's a pretty mature notebook. The cool part about Zeppelin, besides that it's very interactive and you can combine multiple things, is that it has multiple interpreters that can be hooked to it. So what I mean by that is that you could have Python code mixed with Scala code, mixed with R code, and you can pass variables between them. You could have markup language, you could have shell commands in Zeppelin. So there's multiple things you could do all in one environment, versus in Jupyter where you would have to specify the language ahead of time. So that's one of the very cool and flexible pieces of Zeppelin, besides all the other integrations that come in with the Zeppelin itself, as you'll get the chance to play with it. Some of the graphs that we were able to integrate with some external libraries and shown at the previous DataWorks summits. Actually, last year at DataWorks Summit in Munich, this was part of the one of the sessions on information is beautiful. So if you Google this one, you'll be able to actually watch some of the slides and pull some of the libraries that have been used. Zeppelin, one thing that's really useful. So you have your notebook authors, you have your collaborators, and via the Zeppelin, you would be accessing a cluster. So it could be a Spark on the back end, it could be a Hive, it could be HBase, and you could be running all these different workloads via Zeppelin by basically specifying the type of interpreter that you want to use. Cool piece about Zeppelin again is that you can do all kinds of workloads. So some of you are data engineers, some of you are focusing on data science, some of you want to do both. And again, in Zeppelin, you can do all those types of workloads. So you do some engineering, you do some pre-processing, and then you do some machine learning, training, and so forth. When you finish with your analysis, you can either generate reports, you can actually have some of the graphs and link them, you can link to them via an actual URL, an actual address. And the other one is, of course, you can actually productize it, you can export models, you can export notebooks, you can share the notebooks, and within the DSX that we'll be using today for the lab, you'll be able to share the notebooks with other users in a seamless environment. Multi-tenancy, very quickly. So what we're going to be using today, so in the lab itself, we'll be using Data Science Experience. And Data Science Experience will be connecting to the Hadoop cluster via Livy. Livy is just a REST server. And one thing they can do is, you have multiple, you can interact with different sessions via Livy. It can kill different sessions. It can kill sessions if they've been on for too long. There's some security that you can do with Livy, so there's some really cool stuff. Let's see what else we got. These are really the key points. So Again, isolation, session sharing. So if you got one session of Spark, you can share the sessions between the different users. Livy, again, for example, recycles, and that's a preset setting you can do after like 60 minutes of an activity. And identity propagation, so sending user identity from Zeppelin to Livy to Spark on YARN. Let me skip these slides. HTTP basics. How many of you have an HTTP cluster? Okay, over half. That's very interesting. So basically what we'll be using today, this is Zeppelin in and of itself. That's the interactive notebook through which we'll be running Spark. And then those jobs will be pushed to YARN, which is, again, the resource management. And the files are stored on HDFS, which is the distributed storage layer. With what we're going to do with Zeppelin itself, Zeppelin today will be in data science experience, and the jobs, again, like I mentioned, will be pushed via Livy to the Hadoop cluster. So we're going to go level up. So different workloads you can do. Probably know about this one. This is, again, you already probably know the entire ecosystem of things that we're not going to touch, from security, governance, and so forth, that are in the HTTP distribution. Here's some simple architecture. You've probably been to a lot of sessions. There's a lot of building. You have your Internet of Things. With one of the other products that we have, HDF, it's great about connecting and bringing all the data to your clusters. And one of the cool tools, which I personally like, and there's some demos that this gentleman called Tim Spann does a lot. He has the Minify, which is running a very light version of NiFi, and basically that brings all the data and runs on devices like Raspberry Pi, on your smartwatches, and it pushes data to NiFi nodes, which are slightly larger, more heavy, and then you can bring all your data into a cluster. So here's a simple flow. So for example, if you're doing streaming, you can have your different IoT devices on which the Minify is deployed. So what I'm doing here is I'm trying to bring and kind of give you a larger picture of things you could actually do. And these are relatively easy. Anybody can kind of pick it up and play with it. So once you bring it up to IoT edges or the single nodes, then you have your NiFi hub or multiple nodes. You would generally push it through a Kafka broker to make sure it's stable, and then you would have your Spark streaming. So for example, in this case, we would push it through a live dashboard. On the other hand, you could also go and store it for long term, whether it's HDFS or in the future Ozone, and then perform some Spark machine learning processing on it and store it in a columnar database. So then, whether it's HBase or Cassandra or some other columnar store, and then you could have Spark streaming reference it, for example, to make quick real-time decisions. So if you had some SLAs that are 60 milliseconds in time, you would reference whatever the results were stored in the columnar database to quickly make that decision. And then you could push it to the live dashboard where you could, for example, have indicators or some kind of alerts that will be flashing on top. All right, let's quickly go what's new and some of the things that are new in the other versions. If you're not in Spark 3, if you're later. So many of the things that will come, such as structured streaming latency. So probably the next version of HTTP will have Spark 2.3. And some of the things we want to push specifically for that reason is there's the much faster processing. So what I mentioned previously was, the Spark streaming, the default mode is the micro batches. The micro batches are not as efficient because if you have SLAs where you need to process something in under half a second, then this won't perform as fast. Instead, when you have the continuous mode, then you can have then you can actually target SLAs for end-to-end processing within tens of milliseconds. So that's a big improvement in 2.3. You can actually do stream-to-stream joins, so you have ads and clicks. You can join the streams together in live. Previously, in the earlier versions of Spark, it was a stream and some static data source that's been populated before. Now you can join two streams. That's actually a cool feature. PySpark supposedly been updated quite a bit. A lot of performance improvements, especially with the Pandas UDFs. And it also runs on Kubernetes clusters. So I'll show a slide where you have different clusters that you can run your Spark on. Previously was the Spark structure streaming, so I've spoken about that already. Yahoo benchmarks show that it's pretty fast. And the big one actually, if you have your Hive files and files stored in ORC format, now there's been a lot of work done to have ORC parity with Parquet. So for a while, Parquet was beating ORC when read in Spark, but now ORC has been updated and made way more efficient to work on that same level. So again, here's a cool slide where you have your different modules. So now, like I showed you, the previous modules with 2-3 big focuses on structured streaming, and all these different modules that we've discussed with Spark SQL and essentially data frames, or the SQL code, the structured streaming, machine learning, and the GraphX. You have the Spark core, so basically everything's pushed down and optimized depending on different module use. And then again, the Spark core can run within standalone mode, so if you want to test it on your local machine, that's a very light way to do it. If you have a cluster that's running YARN or Mesos, or now Kubernetes with 2.3, you can actually push it down to those nodes as well. This is again with the comparing the Parquet to RC. Let's see, this is a bad resolution, so let's see if I can actually read this. Yeah, so this is the old ORC file, so you could see the actual time to process was quite long. This is the Parquet performance, and this is the new ORC. So a lot of improvements have been made. This is an aggregation on 10 terabytes of geomean total runtime, yeah, okay, on TPCDS. So basically many different queries on TPCDS, and this has been averaged to how these different queries do perform. Yeah, this is a total runtime of 74 queries. So quite a bit of improvement, and a lot of work has been done over a few years to get to that point. So again, the benefit of Apache Spark, you have your speed. You can use Spark both in column or batch or ORC format together seamlessly. You have the stability with the ORC, usability, and then of course maintainability, because you have all your data in Hive, for example, in ORC, so you can reuse it here for quick performance. You don't have to duplicate the data to convert it to Parquet anymore, so it stays one columnar format and you get good and fast performance. All right, so these are again the 4 code pieces that we've discussed today very briefly. It's about 50 minutes right now, so it's a good timing. So Spark SQL, Spark Streaming, Spark MLlib, and Spark GraphX. Again, on the Spark core, which translates and optimizes everything for you. And before I go, any other questions at this point? All right, cool. So briefly introduce you to this one. So what we're going to do today, the lab itself is the DSX, or Data Science Experience. And I wanted to do it today. If some of you are coming to the Data Science session, I want to make sure that you get a chance to play around with it, get a feel for the environment. So tomorrow when we do focus on data science, we actually can jump in and focus on some other pieces of the environment itself. Today we're going to do a very basic Spark in 5 minutes tutorial. You can find that tutorial on our webpage, and if you need to test it, you can download the actual HTTP sandbox and run it there. But for today, I wanted to make sure that it's hosted for you. So we're going to be connecting to 5 different clusters of DSX. The DSX right now runs on the Kubernetes cluster, and it's not integrated with HTTP at this point. So what it's going to be using, again, this Livy REST server, which is going to connect to Hortonworks, where, of course, you have your enterprise compute and storage. We'll be using, again, the Zeppelin notebook, and tomorrow, if you come to the session, we'll be focusing on a Jupyter notebook. So again, you have 2 different ways, Python code in both to make it easy for everybody. And that's that. And the lab itself, okay. Any questions before we go to this point? So what I'm going to do is, this is the actual URL. Let's take a 10-minute break. You can go to this URL to see what's going on. And after the break, I'm going to go and show you what's the lab all about. Sounds good? All right. Actually, one more thing. So for the lab itself, if you could find a partner, so this way the two of you would work together on the lab itself. So please find a partner next to you, join the forces, so this way both of you run the environment, and this way you can help each other to go through the actual experience. So yes, so did everybody get this picture? Yeah, go. So once you go to this URL, yeah. So basically, what the endpoint will be having this notebook and running through this notebook and going through the different pieces of the code. So essentially, what will happen is you'll get to explore and test this notebook out and see the results, and also get to know a bit of this environment and see how everything works. Okay. So once you go to the URL, let me double check. I should have another window open, and I'll talk about it briefly. But first, I want to make sure that you guys get a chance to take a 5-minute break if needed, because it's been 50 minutes already. Let me see. Okay, I have to copy it myself. So when you open the URL, is anybody having Wi-Fi problems? Excuse me? Okay. I'm having problems. Excuse me? Yeah. Can you open the Google Sheet? You can open. Okay. I'm just having Wi-Fi problems. Why? Okay. Yes, yes. So as you go, I don't know, how many people do we have, do you think? We have, I think it's more than 50. 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so if, definitely, oh, okay, here I am. So, yep, so there are 5 clusters. It's good that people are going to different ones. So essentially what I want you to do is I want you to put your name next to the cluster that you want to use, and then this will be your user. Actually, probably can't see it, sorry. Let me go, large. And I want to make sure that, yeah. So this is the URL, the tiny URL that I've shown on the, I'll show you again. This URL. It's not up? It's there, it should be there. Has everybody been able to reach that site? Okay. Anybody that hasn't been able to reach it? 1. Okay. Are you just not connecting, or? 1 moment, let me check. Fantastic. All right. Who deleted that one? I thought I protected that one. You guys. Actually, I gotta open this one. Boom. Oh, cool. There's a lot of Hortonworks stickers and community stickers, and I'll talk about community a little bit later. Thank you, Raphael. All right, should be good. It's actually protected. Okay, let me just wait 3 more minutes, and then I'll go over this in more detail. Oh, great. Thank you very much. Which one? 1 and 5 is not available. All right, let me just wait a few more minutes. All right, let's see. We got a minute and a half. Let me just ask something. Back. Right, yes, yes. Super diverse class. Okay, so it's a time, so let me tell you what we have here. So I am seeing that most of you already have gone to the cluster. Put your name next to it. 2 things. Excuse me? Yeah, anybody that did not enter the cluster yet. The URL, which one? Number 5. Okay, can you just copy and paste it? Okay, let's see. If I go, let me double check. Privacy error. You were not able? I was just able to do it. So if you're having issues, you can work together. If you know. Oh, you have the same. Oh, that is a problem. So you could try 3. There's some room there, or actually number 2. Not that many people number 2. So just remove your name from 5 and put it here. Approval. So okay, let me just get there in a moment. So before I go, 2 things that I wanted to tell you. So again, I see cluster 1 is full. That's good. There's some room on cluster 2, cluster 3 and 4. The reason why it's better to have fewer users is because it spins up. The DSX spins these pods for each and every user group, and then when you actually spin up Zeppelin, it creates these massive pods. So it's actually quite resource hungry, but we should be able to handle up to 10 users with this small 3-node clusters. One thing I want to do, so you can see there's some tabs on the bottom. Hopefully you can see on that side at least. Like emails, if you want me to send you some of the slides of this presentation, I'll forward you the slides of this one. Yep, exactly. I know I've been going fast. It is a crash course, so it's not a training. If you want all this that I've said today in very detail, I highly recommend that you take a full-day training course. We have fantastic trainers. But the whole idea is to really give you a high-level overview and then get your feet wet with a simple notebook like you're going to be doing in this lab. Also here, I've provided some links. I've actually recorded videos going at a much better, slower pace than I did today. The Spark Crash Course 5 pieces, they're on YouTube. Basically covers the same material, so you can rewatch it and then be like, that's what Robert was talking about. I'm glad he's got those videos. Also, there's Hortonworks Community Connection, which is essentially a Stack Overflow, but for big data. We have a growing community, and I'll go over that later. Which is actually very neat. We have a lot of assets, a lot of articles, and a lot of hard questions have been answered by our SCs. So please do so, or if you want me to look at something that I might have missed on blogs, definitely add that too as well. With that, so here are all the, I see that people are using the DSX. The actual instructions are over here at the very top, getting started instructions. So once you click that link, you should be going to this one. So here I go over in detail well, not that much detail, but most of the detail of how to get started. Some of you might be seeing this error, I cannot log in. That's because we don't set up certificates on these and there's no security connection. This is the message that would probably appear on Chrome if you're using. So you just click Advanced. You just click this one, proceed to proceed, even though it's unsafe. It is safe. We've secured it, but there's just no certificate. So anyways, once you sign in with your user and password, then you should be getting to this screen, which is the main project screen. And basically, we're just going through some of the flow of creating the projects. Let me make sure this is larger here. So in the top right corner, you just click the Create Project. Then you specify the name. Make sure that you append the actual project with your user, just in case you're using the same Spark Crash Course name over here. This way there should be no contention. Actually, this won't work in this case. But if there is contention, just add a few letters and we should be good. There's only 15 projects. Then, of course, you go to the assets part of actually importing notebooks. So click on the assets in your new project, and then you click the Add Notebook. And once you click the Add Notebook, we're going to be going and selecting this via URL. So basically, all the different pieces. So on your Create Notebook, you click the From URL. You specify a name, whatever you want to be. I don't think there should be contention on the notebook names, but if there is, just add a few letters again. Then this is the actual link, which is here below, or actually no, this is the link right here. Just copy this link for the notebook itself. I posted on my GitHub account. So this is the actual URL for the Zeppelin notebook. And in the environment, then just select you want to go with Zeppelin with Anaconda 2, which a lot of the machine learning libraries, and Python 2.7. And then you hit Create. Once you've done that, after a minute or two, or if there's a lot of contention, maybe a few more minutes, you should have this notebook pull up, which is the Spark in 5 minutes. Yeah. Were you not able to get into this? No? This link is, it's at the top of the spreadsheet, right? How we're getting started instructions. Yeah. Sorry. So again, let me zoom this out. All these instructions step by step are right over here. The very top. Almost very top. Right, to the top. Closer. Right, yeah. All right. So everybody seeing the instructions? Everybody going through setting up? Awesome. I love it. Like, yeah. So let me go back to my environment. So who hasn't gotten to this point yet? Okay, 2. Yes, let's wait a few more minutes. Walk around. All right. So hopefully all of you got to this point. And what I'm going to go through is briefly what the different pieces are and show you a little bit about the Zeppelin environment. Oh, shoot, this is not looking that. That's interesting. In a full screen, it's cutting off some things. Let me see if I can launch it here. now there's everything. Cool. So one thing that you will see is that underneath this image, if you click the editor, is an actual markdown code. So this is the markdown code that generated this image. So basically we point it to an external image, and then it's a markdown that's been generated, and as it is in the description, if you hit this triangle button, you will actually run the paragraph. Another option to run the paragraph is just by pressing Shift and Enter. So I get a Silicon Valley data set. If you've been watching the show, you know exactly what I'm referencing. Here's a brief description if you need more info. A little bit more on Zeppelin. If you need more of a hands-on holding, there are some links that you can go to. And of course the official Apache site. More links to Spark. I've described this one. And again, these are the different interpreters that are used within the notebook itself. You've just seen the markdown interpreter over here, which is basically percentage %MD. So for the other ones that we go over here, we'll be using the PySpark interpreter, so having Python code with Spark itself. We're also going to be using the SQL. So this is the part where the Spark SQL module has the Python code actually dealing with the data frames, and then we register a temporary view to deal and run and write SQL code to do the same type of workload. So basically two different ways of performing the same type of actions, and previewing some of the results. So when I go and actually show you the edit of this notebook, you see that right here I'm specifying a PySpark interpreter, and all I'm doing here is checking the version of this notebook when it runs. Actually, let me double check one thing. Oh, I know why. This is my personal notebook. I need to be VPN. Cool. So again, a very easy way to check what Spark version you have when you actually run this paragraph, or it's called paragraph in Zeppelin, and Jupyter will be called a cell. Get the Spark started, and let's see, this will run a moment. In the meantime, the other paragraphs that are here, basically we're importing a JSON stored data about the episodes, and it's a typical Python code to actually read the file and write it as output to a temporary directory. And that what we're doing is we're using a JSON reader to actually extract the data with the data format itself around that data. And I'll show you in a moment when this finishes, hopefully. I may need to restart something. Actually, there's another thing I can do. So here's another notebook, and I wanted to show you one thing. So the notebooks that you're running, they're all running locally to DSX. So we're not even hitting an HTTP cluster. They just have, those have a Spark bundled within itself. So small clusters, small Spark for this very light job. What this one is, this is a notebook that actually we have, and we show this environment during customer presentations. This one is actually using Livy. So when I'm hitting this one, I'm actually hitting an HTTP cluster. So this one does the REST interface, right? So this is, as you can see in this interpreter, I'm going livy.pyspark. And if you want to check the interpreters before I go on, if you click on it, here are all the different interpreters that have been set. So you have the Angular, JDBC connection if you need to do some actual database querying. These are all the Livy settings. So again, it's like Livy will be the default Spark. Livy.SQL would be the SQL, PySpark, etc. Markdown, pure Python. You can just write Python in the cells and execute just Python, so it wouldn't be sent as a Spark job, right? So if you just need to do some Python exploration, you can just do that one, and then you adjust the code to actually have your Spark equivalent. If there are some changes needed, you got your shell, and of course the default Spark that you guys are using in your version of DSX. So let me go back to the notebook. So once you execute, you should basically see this message that the actual data frame has been populated and computed. When you actually print the data frame, now you can see that there's a schema. So as you remember, there were the rows, the columns, and of course schema attached. So this one has a schema attached, so it knows what the data is like, and it can infer the values as well. So it knows whether it's a string type or a long type, etc. Here I've generated a table. As you recall, there's also an Angular interpreter. So here's just my typical HTML code to generate a table like this. So this is actually very useful if you want to combine graphics with a few other things in your notebooks. For example, if you're communicating or giving instructions for someone else who's more like an analyst than a developer, then you can add a lot of the markdown HTML code to do that as well. And of course, since it's Angular, it can be a lot of the dynamic HTML code here as well. Then all I'm doing is I'm just previewing what's the information in my Silicon Valley episodes table. And at this point, what I'm doing is I'm registering the temporary table or temporary view, what's called nowadays, in Spark itself. So when I do that, then I specify a different interpreter, livy.SQL, and I can write a SQL code here to query the Silicon Valley episodes temporary view. So you're seeing the difference. So as you remember, the code that I've demoed during the presentation is basically two different ways. One is the data frames. I write the code, and here I just write the SQL queries to have the same results and provide some other information. Make sense? Cool. As you go, you can see there's different ways of looking at the graphs. If the information is useful, you can have, can quickly switch between bar charts, pie charts, and the cool part is that a lot of these things are built in. And then basically what we're doing is, we're doing just raw transformation. So again, we're building on, we're basically looking at the summary column in our data frame, and then we're doing several transformations such as flat map. We're splitting some text on empty, and then we're also removing filtering words that don't exist. So basically empty rows. And then we're lowering everything to lowercase. So basically we're looking at what are some of the most common words. Very simple, word count. What are the most common words in this text that we've just imported? Here's previewing some of them. These don't have a count, so then we add the classical 2-hour words function and calling it word number. So basically you have a word and one attached to it, and then what we're doing is the classical reduce by key and basically doing a count. So reduce by key is an efficient way of actually doing this count and aggregating it. And then what we do is we want to filter the results by counts that are greater than 10. And since it's a very small, we push a function called collect. So we collect everything. This will fit in memory because it's actually tiny. In a production system, you don't want to do it because you want to bring all that information, but here it's fine. And then we're printing the results. And basically the results show that, the most popular are the actual names, the characters of the Silicon Valley show, such as Ehrlich, Richard, words such Piper, because it's Pied Piper, right? Their company, Jared, and so forth. And that's it. So you should be able to run through this notebook successfully. It's a very small notebook, but I hope it gets you started. We have a lot of tutorials that go more in depth if you're going to Hortonworks. So basically, this is the first tutorial that you see when you go to the Hortonworks Spark tutorial page. This one you can run on your HTTP sandbox locally, but this environment will be up for a little bit longer. So if you want to import other notebooks and play around, this environment will be up till about 9 p.m. So I'll let you do that. If you've been able to successfully run through this one, there's other notebooks that actually come with this environment as well. So if you look at this project list, actually this is a different one, but you should have something like DSX samples, which has a lot of different notebooks as well. And if you click on the assets, that's when you actually see all the notebooks. So there are other notebooks that you can explore, but I want to be sure that you're mindful that each cluster is shared with everybody else. So as you're done with a notebook, make sure to terminate your environment so that you release the resources. As you go to the environments in a moment, you can see all the different environments that you're using. So for example, right now I've got the Spark Crash Course project, right, that I've been showing you, I've been demoing. So this one's running, and another Livy environment that I had running as well. So make sure you stop these before you spin up another one. So this way there's a good resource sharing, and you can, and then we don't crash the environment for everybody else. Does that make sense? Cool. Let's see. Another thing, let's see, monitor projects. Yeah, you don't have admin privileges, so you won't be able to monitor resources, but that's fine. This is all you need. This will be for user specific. If you, again, click on this one, drop down community, and click on your environments, you will only see the environments that are related to you, and thus you can control and make sure we're all super happy. All right. Has everybody, okay, maybe a different way. Who hasn't been able to run the notebook? Boom, excellent, man, I am happy. Cool, awesome. So let me finish the presentation, and then we can make it an open session if you guys want to play with other notebooks. I haven't played with many of them, so I really don't know, won't be able to help you, but you can preview them. I think there's only one more notebook that's pre-bundled here that's in Zeppelin. All the other ones, I believe, are in Jupyter. And tomorrow we'll be playing with Jupyter if you're going to come to the data science section. So with that, let me finish some of the slides, and then we'll just make it open for one-on-ones and etc. As I mentioned, again, this is the Hortonworks community. You have that link in that spreadsheet, but also if you go just community.hortonworks.com, you'll see this entire environment. If you have, and if you use this before and you have suggestions, concerns, anything like that, Raphael in the back is responsible and manages HCC, so you can tell him what you like, what you don't like. It's always a great feedback. And we have a lot of assets. This was one of my latest updates, but maybe Raphael can correct me if I'm wrong on any of these. And then, of course, we have a lot of meetups, Future of Data meetups. There were some of the Future of Data meetups yesterday. Hopefully, you've been able to check out some of them. If not, we have all these cities right now and constantly growing and expanding on the Future of Data meetup. So if you want to network with some of our committers, some of our developers, sometimes founders, and other community partners that we invite to host these meetups as well, this is a great opportunity and always a great platform to ask good and relevant questions. With that, I'm going to finish the official part of a Spark Crash Course. If you want, we can open this for any other questions. If not, we can just chat one-on-one. I'm here, Raphael's there. He's also an expert, and we exchange a lot of great ideas often, so we're both here to just chat with you. And if you want to just play with the environment, again, the environment will be up till 9 p.m. today local time, so go at it, have fun, and that's that. Cool? Awesome. Thanks.